start a pretty major topic in math now, which is called systems of equations. In this video, we'll introduce systems of equations, we'll solve them by graphing, and we'll discuss the importance of the solution in a system. So really in this chapter, one thing we're going to learn how to do is we'll talk about how to hit moving targets, mathematically, really. So compare these two problems. In problem 1, you have $20 and earn $15 per month. How long until you can buy a switch for $300? This is a problem that is very simple to solve, and you've solved many times before problems like this. There's only one thing we don't know. In problem 1, the only thing that we don't know is how much time it takes. How many months do we need? That's our variable. X equals number of months. But I can just set up 20, I'll do 15x plus 20, and I need that to come out to 300. We start out with $20, we add 15 per month, it has to equal 300. So it's almost like it's a slope-intercept form, y equals 15x plus 20, but we know what we want the ending amount to be. We want to end at 300. So we can just solve this. Subtract a 20 from both sides, and you get 280 equals 15. 15x, divide both sides by 15, and you'll get that x equals, some not whole number, really. 280 divided by 15 is 18.7, which means we would need 19 weeks. At week 18, we would have just a little bit too little money, so we need one more week, 19 weeks, to save up enough money. But this problem is pretty simple to solve because there's only one variable, there's only one thing we don't know. Okay, the only thing we don't know is how long it takes, how much money we'll need. That's going to be very different from the next problem. The next problem says you have $20 and earn 15 per month, but the cost of the switch is changing. If a switch costs $300 but drops in price $5 each month, how long until you can afford one? Well, now we can assume it's not going to be 19 weeks anymore because we'll have enough money faster because the price of the switch is falling. This is the moving target. The price of the switch is moving, but our total money we have is also moving. One's increasing while one is decreasing. In this problem, there are two things we don't know. We don't know the number of months that we'll need, but we also don't know the amount of money we'll need. We know it's going to be less than 300, but we don't know how much. Since there are two things we don't know, we have to have two equations. That's what a system of equations is. A system of equations is two or more related equations. So let me show what those are. Our equation, so x is number of months, y is amount of money. For our money, how much money we have, that equation is y equals 20 plus 15x. All right, 15x plus 20 to put in slope-intercept form. I'm earning 15 per month, and I have 20. This shows how much money I have every month. In 1 month, I'll have 35. In 2 months, I'll have 50. In 4 months, I'll have 80. The other equation, though, is the switch cost, the cost of buying the switch. That is going to be y equals negative 5x plus 300. It starts at 300, but drops by 5 per month. Some books are getting in the habit of writing it like this, saying start at 300, drop by 5 per month. Either way is fine, doesn't matter. Just know that the one with your x attached to it, that's your slope. Okay, so we need to solve this system. We want to find how many months it takes for us to be able to buy the switch, and also how much it'll cost if the price is dropping $5 per month. So the first thing we're going to learn is how to solve by graphing. Okay, we're going to solve the system by graphing. Eventually, we'll also learn to solve by what's called elimination and by substitution. So there's 3 ways to solve. We're going to start by graphing. But before we get too into this, let's ask the question. Here's an important question, and I ask this question in a lot of my math classes. What is a graph? Will you pause and think about that for a second? Although, before you pause, I'll tell you, this right here, not a graph. This is called a plane. It's often called the coordinate plane or the Cartesian plane. The plane is the space upon which we graph, but is not a graph itself. So graph paper is called graph paper not because it's a whole bunch of graphs in paper form, but because it's the paper upon which we graph. So knowing that this is not a graph, will you please try to answer the question, what is a graph? Pause it, do that, think about it. I'm sure you actually paused it and thought about it because that's the type of student you are, so thank you very much. You might have said things like data or points or a slope and an intercept, and all those things are parts of graphs and components of graphs, but here's what a graph really is. The wordy mathy answer is it's a visual representation, and in algebra, we'll be specific, a graph in algebra is a visual representation of the solutions to an equation. You can think of it as a picture with the answers. So I'm going to graph an equation. I'm going to graph the equation y equals 1/2 x minus 2. Let's do minus 3. Let's do minus 4. That starts at negative 4 and goes up 1, right 2, and down 1, left 2. This is the equation of the line y equals 1/2 x minus 4, and this is the graph of the line. So I just did the graph of the line 1/2 x minus 4. But what is that graph? What is that graph showing us? That graph is actually showing us every possible solution to this equation. And by solution, I mean I can pick any point. Like here's the point negative 2, negative 5, right here. I can pick any point on this graph and plug it into the equation, and whatever comes out will be true. So here's my x value and here's my y value. Plug in negative 5 for y. 1/2 times negative 2 is actually just negative 1. Half of negative 2 is negative 1, and negative 1 minus 4 is negative 5. Hey, look, it's true. Negative 5 does equal negative 5. I could also pick this point, which is like 0.5 comma negative 3.75. If I wanted to plug that in for x, I could plug that in for x and y and see if it works. There's all kinds of things that I could check to plug in. Every single point on this line works, and equally importantly, every point not on the line doesn't work. The point negative 1, 3 won't work, it's not on the line, and the point 2, 4 won't work. If I plug in a 2 for x and a 4 for y, I'm not going to get out a true statement. Let me show you. If y is 4, well, 1/2 times 2 is 1 again. 1 minus 4 is negative 3. Negative 3 does not equal 4. Hey, look, it didn't work. So a graph is showing every single possible point that can solve an equation. It's actually a really, really useful picture of just everything that could possibly work, which is kind of nuts because it goes on forever in both directions. At least if the graph is a line, it does. So, let's go back to this problem. You have $20 and earn $15 per month. A switch costs $300 but drops in price $5 each month. How long until you can afford one? Remembering that X is going to stand for months and Y is going to stand for money. We had the equation for us and our money. When you have this, it's $15 per month starting at 20. And for the switch, it's $300 dropping by 5. So here we are on Desmos. Desmos is a great way to do some simple graphing and calculations. So I don't want you to use it on this upcoming homework, but we'll do it in the future just so we understand how it works. The red line here is showing how much money I have or you have. You'll note way down here it's starting at the point 0.20 and it's going up forever. If I just scroll along, I can see in 6 weeks, 7 weeks, 8 weeks, or 8 months, how much money I have. Obviously, we're not getting money like every single passing instant, so the fact that this is a whole complete line doesn't quite make perfect sense, but we get the idea. Here at month 5, I have about $95. The blue line is showing the cost of the switch, and the cost of the switch starts at $300, but is going down forever. We need to see where do these two lines cross, because the point at which they cross is where the two things cost the same. Okay, that's incredibly important. The point of intersection of these two lines is going to give me 2 bits of information. The 14 tells me when it happens. If x is 14, that's telling me when the two things cost the same. The 230 is how much they cost. So by this point of intersection, I can tell in 14 months a switch cost $230. That's much faster than 19 months when it was going to cost $300. It saves me 5 months, which is a long time in the world of wanting to be playing video games. So the point of intersection is the single point that solves both equations. That's incredibly important. The single point that solves both equations and therefore solves our system. So it's going to take 14 months and the cost is $230. Okay, well, let's actually do it together by hand. It won't be a word problem. We're just going to graph this system and find their point of intersection. That's how you solve the system. Then we'll check. So this first one up here, y equals 2/3 x plus 4, is in slope-intercept form. I'm going to start at 4 and go up to right 3. But since I can't go up and right anymore, I'm going to go down and left because that gives me the same slope. So I'm going to go down to left 3, down to left 3, and that's all I can fit on this plane. So I'm going to connect these with a line. Make sure your line extends across the whole entire plane, and make sure that you're putting down dots in a very accurate manner, counting out the slope each time. Point, 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 point. Otherwise you can drift and it won't work very well. Okay, the next one is in standard form. ax plus by equals c. Right now my a value is 4, my b value is -2, my c value is 16. I know the x-intercept is c divided by a, which is -16 divided by 4, which is -4. So my x-intercept is right here. I'm going to do it in light blue at -4, 0. The y-intercept is c divided by b, which is -16 divided by -2. Note that it's -2, so that's the point 0.8. I can't quite fit 0.8 on here perfectly, but I'm going to do my slope next. Remember, the slope is -a divided by b, which is -4 divided by -2. Right, if it's -a divided by b, right now the b value is, or the a value is 4, so that's -4 divided by -2, which is just 2. So the slope is 2/1. I don't want to try to draw this line right here because this point up on top isn't super accurate. I'm not sure if that's correct. And if I look really close at this intersection, it's not exactly on a perfect point. It's crossing just off that point, and I don't really want that. So what I'm going to do instead is count out my slope from a clean point really well. I know that the point -4, 0 is correct. I know this point right here is good. So I do my slope. Up 2, right 1, up 2, right 1, up 2, right 1. Down 2, left 1, down 2, left 1. That looks a lot better. Now their point of intersection, clearly at the point -3, 2. -3, 2 is the point that solves both of these equations. I need to check that to make sure. So I'm going to check -3, 2 in both equations. I plug in 2 for x, 2 for y, and -3 for x. And I want to see what that equals. That means that I get 2 equals this -3 and this +3 cancel, so it becomes a -2 plus 4. -2 plus 4 is 2, so the first one checks. Okay, now I'll check the second one. I'm going to check this equation here. I'll have you structure your work a bit better than this. I'm trying to display things, so I'm just trying to show everything, but I want yours to be organized quite a bit better. I'm going to plug -3 in for x and 2 for y, and I get -12 minus 4, which actually does equal -16, so it checks. The point -3, 2 solves the system. And I'm not sure if you're familiar with set notation. Set notation is when you use brackets and stuff. So to get better with set notation, let's write it like this. The point x comma y is in the set And that backwards looking 3e thing means in this set, negative 3 over 2. If you wrote this for your solution and put it in a nice big box, that's beautiful. Should be in parentheses also. So then a couple things to keep track of. I'm going to label these equations. This one here was y equals 2/3 x minus 4. I'll do this one first. This equation right here was 4x minus 2y equals 16. The reason we have to label equations is so we know which one we're graphing, which one we're looking at. This one here was y equals 2/3 x plus 4. I'm going to make sure I at least label the point of intersection, but labeling a few other points can be nice. I should have done that in pink. And here's the point -5, -2. Graph your two lines, see where they cross, label the lines, find the point of intersection, check the point of intersection, state your solution. Seems like a lot. It's really just doing lines twice. So basically, the number of problems I'll give you compared to previous graphing assignments is going to be half, because they're all twice as much work. So I get this right here is a big page full of stuff, but I'm going to give you not too many of them on homework, and we'll have plenty of time to work on it together. Graph, see where they cross, grab that point, check it. Okay, thanks for watching. Till next time. We did it. We got through another math video. Thanks for watching. Here I'm going to play with the perspective on these shapes while I talk to you. Please subscribe to the videos, like the videos. Okay, let's start this thing over. You did it. You got through the video. Thanks for watching. I'm going to play with the perspective of these shapes, which is always pointing towards that center while I talk to you about things. Please subscribe to the video. The channel, really. Please like it if you found it helpful. If you want to share it with friends and say, hey, this guy's not the worst, that's an option too. You can always take your video quiz if you're in my class. And comment down below. See you next time.